Question 242. How do you approach designing and optimizing digital signal processing pipelines for efficiency and scalability? Can you provide an example of a complex DSP pipeline you designed? I design DSP pipelines by breaking down the processing stages, optimizing each stage for performance and ensuring data flow efficiency. For a radar signal processing system, I designed a pipeline with multiple stages for signal filtering, feature extraction, and target tracking. Question 243. How do you ensure the reliability and robustness of DSP algorithms in safety-critical applications? Can you discuss your experience working on projects with stringent reliability requirements? I ensure reliability by rigorous testing, fault tolerance mechanisms, and adherence to safety standards like DO 178C. In a medical imaging project, I developed DSP algorithms for real-time image processing with strict reliability requirements for accurate diagnosis. Question 244. How do you approach optimizing DSP algorithms for cloud-based processing? What are the challenges and considerations when moving signal processing tasks to the cloud? I optimize DSP algorithms for cloud by leveraging distributed computing, scalability, and parallel processing capabilities. Challenges include latency, data security, and network bandwidth limitations, which require careful consideration when migrating signal processing tasks to the cloud. Question 245. Describe your experience with integrating DSP algorithms into embedded systems. How do you ensure efficient utilization of resources and real-time performance in embedded DSP applications? I have integrated DSP algorithms into embedded systems by optimizing code for memory and processing constraints, using fixed-point arithmetic, and minimizing overhead. Real-time performance is achieved through careful resource allocation, task scheduling, and hardware acceleration. Question 246. How do you collaborate with cross-functional teams, such as hardware engineers and software developers, to integrate DSP algorithms into a system? Can you provide an example of a successful interdisciplinary collaboration? I collaborate by clearly communicating requirements, sharing design specifications, and coordinating testing efforts with team members. In a project involving sensor data processing, I worked closely with hardware engineers to optimize signal acquisition and software developers to implement the DSP algorithms seamlessly. Question 247. How do you approach optimizing power consumption in DSP applications for battery-operated devices? Can you share a strategy you implemented to reduce power consumption in a DSP system? I optimize power consumption by minimizing processing cycles, using low-power modes, and implementing efficient algorithms. In a wearable health monitoring device, I implemented a power management strategy that dynamically adjusted the DSP processing frequency based on workload to extend battery life. Question 248. How do you ensure the security and integrity of data processed by DSP algorithms in IoT applications? Can you discuss your experience implementing data encryption and authentication mechanisms in DSP systems? I ensure data security by implementing encryption algorithms, authentication protocols, and secure communication channels in DSP systems. In an IoT project, I integrated cryptographic libraries to encrypt sensor data before processing, ensuring data integrity and confidentiality. Question 249. How do you approach testing and validation of DSP algorithms to ensure accuracy and reliability? Can you describe your experience with developing test plans and performing verification of DSP systems? I approach testing by defining test cases, creating simulation environments, and conducting thorough validation of DSP algorithms. In a radar signal processing project, I developed test plans to validate signal processing algorithms against ground truth data, ensuring accuracy and reliability in real-world scenarios. Question 250. How do you prioritize and manage multiple projects simultaneously as a DSP engineer? Can you share a time when you successfully juggled multiple project deadlines and deliverables? I prioritize projects based on deadlines, criticality, and resource availability, using project management tools to track progress and allocate tasks efficiently. In a recent scenario, I managed multiple projects by setting clear milestones, delegating tasks effectively, and communicating progress updates with stakeholders. Question 251. Describe your experience with continuous integration and deployment in DSP software development. How do you ensure code quality, reproducibility, and version control in DSP projects? I have implemented CI/CD pipelines for DSP software by automating build processes, running tests, and deploying code changes seamlessly. To ensure code quality, I use version control systems like Git, perform code reviews, and integrate automated testing to catch errors early in the development cycle. Welcome to CloudRoar CSPM, your intelligent cloud security posture management platform. In today's hybrid and multi-cloud world, maintaining visibility and control across AWS, Azure, and Google Cloud can be complex. CloudRoar CSPM simplifies that by continuously scanning all your cloud accounts, configurations, and workloads. Our platform automatically detects misconfigurations, compliance violations, and potential security risks before they become incidents. CloudRoar CSPM provides clear, actionable insights mapped to major frameworks like CIS, NIST, and ISO standards, helping your teams remediate faster and stay audit-ready at all times. Strengthen your security posture, achieve continuous compliance, and take control of your multi-cloud environment with CloudRoar CSPM, security that's smart, scalable, and proactive. Introducing CloudRoar Cost Optimization, your unified platform for smarter cloud spending across AWS, Azure, and Google Cloud. Cloud costs can grow silently, but CloudRoar gives you full visibility and control. Our engine continuously analyzes usage patterns, instance sizing, and idle resources to uncover hidden savings. With intelligent recommendations powered by real-time data, CloudRoar helps you right-size resources, eliminate waste, and maximize return on every dollar spent in the cloud. Get detailed reports, actionable cost insights, and automation that ensures continuous optimization without compromising performance. Optimize confidently, scale efficiently, and make every cloud dollar count with CloudRoar Cost Optimization. Efficiency meets intelligence. Welcome to CloudRoar CSPM, your intelligent cloud security posture management platform. In today's hybrid and multi-cloud world, maintaining visibility and control across AWS, Azure, and Google Cloud can be complex. CloudRoar CSPM simplifies that by continuously scanning all your cloud accounts, configurations, and workloads. Our platform automatically detects misconfigurations, compliance violations, and potential security risks before they become incidents. CloudRoar CSPM provides clear, actionable insights mapped to major frameworks like CIS, NIST, and ISO standards, helping your teams remediate faster and stay audit-ready at all times. Strengthen your security posture, achieve continuous compliance, and take control of your multi-cloud environment with CloudRoar CSPM, security that's smart, scalable, and proactive.